Okay, so someone asked me basically, how do I see this equation practically in the real world? E equals mc theta t. Other people might write this as E equals mc and then that sign over there. So remember when you have water, which is boiling in a kettle, right? You have your water, it's boiling. Whenever you apply something called heat, when you have a flame over or your kettle in this case, you need the water to change basically from the state or temperature in which it was. Maybe say from 0 degrees Celsius, this is nearly frozen, but just for practicality's sake, over to 100 degrees Celsius. So what happens here, this is what we call a change in temperature. So from 0 to 100, that's a change in temperature by 100 degrees Celsius. But for simplicity or for the demonstration of our use case, we're just going to make it simple. And we're asking ourselves, this is the water, this is the bubbles, this is the heat energy which is applied. How much energy or heat do we have to apply to increase the temperature of this water from 0 degrees Celsius up to 1 degree Celsius? Well, chat, that is where the concept of specific heat capacity comes in. So that can be calculated by this formula which is here. So specific heat capacity itself, more specifically, ba, 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 ba. Dang. So specific heat capacity is just saying how much energy do I need to apply to this boiling water, which is exactly 1 kilogram, for it to increase from the temperature of 0 degrees Celsius to 1 degree Celsius. That's what this formula is. So if I were to plug it into the equation, the mass would be 1 kilogram, 1 multiplied by the specific heat capacity of water, which for some odd reason, I am so sorry, I have memorized, is 4,200. This number, I'll verify this later. And then the temperature change which we want, which is 1 degree. So if you multiply that, you can already tell that, okay, in order for me to increase the temperature of water from 0 degrees to 1 degree Celsius, I'll literally need 4,200 joules degrees Celsius inverted, and then kilograms inverted. Or if you want to be specific, that would look something like 4,200 degree joules Celsius kilograms. So yeah, that's the mathematical representation of basically boiling water and increasing it by 1 degree Celsius. In engineering, the same principle applies to, say, metals when you're working with other forms of matter as well. So it's kind of important to have these numbers in your mind. Because every time you apply heat or you use heat energy and you apply it to a metal, according to the kinetic theory of matter, the small particles start to vibrate. So if it's a metal, if it's a railway line, it will mean that the tracks will probably have to expand and then contract to cater for when the temperature also drops. That's another practical use case of this equation. I am so sorry for going off the rolls, but I just had to get this out of my system now that I started talking about it. So yeah, peace.